The objective in this practice is to learn how to use the beakers, the Brinell and the rock wool. Also, we are going to learn how to use them and the procedures we need to follow in order to test the hardness of the steel in this case.
I'm out of excuses, I know it was.
Rod weld machine is used to measure the hardness of a piece. First, you need to calibrate the machine with this piece of metal. You put it here and you adjust, and then you apply a force. And here you're going to get the results. The black numbers are for the hard materials, and the red ones are for the soft materials. And after that, you need to compare the result you get here with these numbers in the table. After that, after you have calibrated your machine, you can apply now the hardness on the material you want to get. You adjust this, you apply the force, and you wait until you apply 2 times. You turn 2 times this, and finally you get the results here in rod wool units.
This is the Brinell, and first you need to modify or adjust the force that you're using with the crank, and then you need to put your material here and turn this until it is in contact. After that, you need to pull this crank, count for 15 seconds, and then push it back again. Then you release the material and you will get a hole like this one, and with this device you will be able to measure the diameter of the circle. For each material you need to make 2 times the process, and after that you get the average of the diameter and you make the calculations. For each material you need to make 2 times the process, and after that you get the average of the diameter and you make the calculations.
This is the beaker's hardness test. You cannot use this link of metal. You have to use a backlight. So for you to use the beakers, you have to put the backlight over here and adjust it, closing this. Using the microscope, you get a clear view over here, and when you got it, you rotate this. If you notice, this has a pyramid shape. When you adjust this, you click on start, and it will have 15 seconds to do a round perforation. Then you change this over to the microscope, and you have to with these two you put the lines over the circle, over the rhombus way, and you get the millimeters. Then for the other side you just change it and have the other sizes of the rhombus. The beaker test use 0.3 kilograms. You use the tables with 0.3 kilograms and check with the diagonal size of that the beakers give to you, and you have the beaker's hardness number. The beaker's hardness test shows that the material 1018 has a practical hardness of 239, a theoretical hardness of 238.11, and investigative of 139. The material 1045 has a practical hardness of 337.5, the theoretical 336.45, and the investigated 370.
For Brinell hardness, we have the results in practical for the steel 1045, that the practical is 284.85, and the theoretical and the investigated we have the same value, is 281.85. And for 1018 we have in the practical 247.89, and in the same way than 1045 we have 2 values, one value for the two spaces. That the theoretical is 286 and investigated the same 286.
We got with the material 1045 a practical result of 23.4, while the investigated one was of 16. On the other hand, with the material 1018, we got a practical result of 18.75, and we couldn't find the Rockwell hardness C, but we find the B that is equal to 71.
These are 5 recommendations to make a proper test. First, you have to verify the lock that you apply. Second, the range of the hardness, the range of the hardness of the material, the precision of the machine, the flexibility of the device, and you have to make sure that it's an economic and it's a suitable application that is the proper method and application, economic and suitable.
The main applications of the hardness test is structural, aerospace, automotive, quality control, failure, durability, strength, and flexibility. These four last, you can use them in this first one, because you can make like the range of failure. An example, in a low in a structural device, or the durability of a part in the aerospace area. Three most important limitations that you can have in your tests is, for example, the load you can apply in your material, the trust in the method that you can do. This gives us the third limitation, that you have to do many tests to have a good average and to have a low deviation, because if we do two of them with a good average and a low deviation, you can trust in one method and you can use that value for all your improvements.
The main difference of these 3 test performance is the indentor that you can use. For example, the Brinell, you can use the diamond indentor, or you can use the steel ball. The Rockwell, you can use the 2 diamond and steel ball, and Vickers, you can use the diamond indentor, but you can't use the steel ball. The Brinell hardness units are kilogram 4 divided by millimeters square, and the Rockwell hardness number most used are HRB, that B is for soft material, and C is for hard material.
Why is it possible to obtain the tensile strength of the steel by multiplying the Brinell hardness number by 500? A convenient conversion fact is that of the Brinell to the tensile strength to the tempo steel is about 50 times the Brinell hardness.
The importance of a good metallography finish for Vickers test is that you can see the diamond figure that you have, and you can measure in the right way, in a horizontal way and in a vertical way.
For me, the most important and the better machine to use to get the hardness is the Vickers, the one that is automatic. Why? Because it gives you the most precisely attitude of the result that you need for know the hardness of a metal.
For me, this is the best machine to measure the hardness of the material, because it gives you the result and you don't need to calculate anything. You just put your piece here and you get the result here. So for me, this is the best machine, but I know also it is the most expensive one.
This practice was really important because for you to design anything, you need to know the material and also the hardness of this material, because if you don't know the hardness, you can't know the durability, or if the material is the appropriate one for the purpose of your design. So it is really important to know how to get the hardness of different materials.
Know the hardness of the material, because you can use it in the design part. For example, if you want to make like a bottle, you can use the proper steel or the proper aluminum to use it for not to crash, or not to make like plastic deformation, or to have like a plastic deformation that can remain permanently there. To make these calculations, this test, because it's really important to know the hardness of the material, because if we know this number, the design that we do will function properly.